All right, so the first thing we have to do is correct the date. So this is actually March 26th because we're behind. But that's all right. Today we're going to be doing balancing equations. Before we get to that, I'm just going to tell you really quickly about diatomic molecules. So what we're talking about is gases that naturally occur in the environment. And they occur as diatomic molecules, which means two atoms. So there's two atoms in one molecule. The elements that appear like this are the ones that I'm going to circle. So hydrogen, and then these six elements here that kind of form a 7. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. When they are a molecule, when you write them in a balanced equation, you never really see them on their own unless they're an ion. They're always written as a diatomic molecule. So this is the list of all of the 7 nonmetals that occur naturally as diatomic molecules. So that's just kind of an aside, and as we write balanced equations, it'll become more clear why you need to know that. So we're going to go over some of the key points in balancing equations, and then we're just going to balance some together. So I'll do one, then I'll let you do one. Then I'll do one, then I'll let you do one. And we'll just go back and forth so you can get some practice and you can see them being solved. So the goal of balancing a chemical equation, you have to have the same number of atoms on each side. So if I'm putting A plus B yields AB, I've got one atom of A and one atom of B on my reactant side. I have one atom of A and one atom of B on the product side. So that's what that means. You have to have the same number of atoms of each element on both sides of the arrow. You can't make a reactant completely disappear, and you can't make something appear in the products. To balance a chemical reaction, you have to use whole number coefficients. A coefficient is just the number that comes in front of the compound. So for example, this 3 that I just underlined, that's a coefficient. You multiply everything in the chemical formula that comes after it by 3. So for the water, you have 3 times 2 for hydrogen. So that means you have 6 hydrogen atoms. And then 3 times 1 for your oxygen atom. I'm going to write a little X here just because it might get a little confusing having the 3 next to an O. It looks like it could be 30. So OX is not what you see on the periodic table, but for clarity in terms of when you're going back and looking at, if you're reviewing this video or if you're writing down your notes, make sure that you know it's not 30 atoms, it's 3 oxygen atoms. So let's do a little bit of practice with counting the number of atoms of each element in a compound. So for this first one, there are 3 elements. There's hydrogen, carbon, and oxygen. Take a second and figure out how many hydrogen atoms, carbon atoms, and oxygen atoms are in 2 of these acetic acid molecules. So for the hydrogen, we'll just walk through this. In one molecule, oh, all right, Flory Elvis, you putting it all out there. Thank you. So let's go through it. You can put up your answers if you want to, and then I'll go through them. So that definitely checks out for the hydrogen, because remember, we've got, let me change colors here. For hydrogen, there's the hydrogen here, and then there's this hydrogen that has a subscript of 3, for a total of 4 hydrogens in one molecule, which means we have 8 in 2 molecules. For the carbon, we only see this carbon once, and there's a subscript of 2, so we're going to say 2 times 2, which is equal to 4. And then same thing for the oxygen. There's a subscript of 2, so we're going to multiply 2 by 2, and that equals 4. Now this next one is an easy one. When you don't see a number in front of the molecule, assume that you have 1. So this just has 2 hydrogen atoms. So don't forget, subscript, that's how many of an element. Coefficient, how many of a molecule. Ooh, my pen just went all types of crazy right there. There. So don't forget, subscript versus coefficient. A couple of other things. We're talking about subscripts and coefficients. We'll go back to our water example. Keisha, did you have a question? Okay. So let's go back to our water example. The 3 is the coefficient. This 2, after the hydrogen, is the subscript. We never change the subscripts when we are balancing an equation. Changing the subscript changes the compound. So you never, ever, ever want to change that. The coefficient, however, you can change. So you change the coefficients to balance the atoms on both sides. Do not change the coefficient, Do not change the subscript. Ever, ever, ever. Don't touch them. So when you start balancing equations, you start with the most complex formula, and then you also balance the polyatomic ions as a single unit, and that will help you if they appear on both sides of the equation. You have to have a whole number for your coefficient. So here, in balancing this equation for making water, there's a fraction. If you have a fraction, you multiply by the denominator, which in this case is 2, so that your new equation is this. So normally you don't write in the 1, but I'm going to write it in here. So you can multiply both sides of the chemical equation to get rid of the fraction. Once you balance, you want to make sure that you have the same number of atoms or polyatomic ions on the same side, or on both sides. So on the reactant side, we have hydrogen and we have oxygen. We have 4 atoms of hydrogen because there's a 2 for the coefficient, and there's a 2 as the subscript, so we multiply those 2 to get 4. For oxygen, the coefficient is 1, so we have 2 oxygen atoms because of the subscript. On the product side, we've got 2 water molecules, so we're going to take 2 times the 2 subscript for hydrogen, and that is 4. For the oxygen, we're just going to take the 2 and multiply it by 1 because that's what's implied there. So this is balanced. That's the kind of check that you're going to want to do after you balance an equation. The other check you want to do is make sure that you have the smallest whole number ratio. So 2, 2, and 4, you can actually divide by 2 and get smaller numbers. We want the lowest ratio. So if you divide everything by 2, and this will make more sense as we do examples, but this is the, don't forget these things. You need to know this for balancing equations. So you can multiply and divide to get the proper ratio, make sure it's a whole number, make sure it's the smallest whole number ratio for your coefficients. So just like with a math equation where if you multiply, you can multiply by 2 or 4 or divide, and you have to do the same thing to both sides. So this is just like doing a math problem. So let's do some practice. And for whatever reason, the internet does not like my arrows. So whenever you see this funky icon here, that's an arrow. So I'm going to show you how to balance an equation. I will balance this one, and then I'll show you another one, and I want you to balance that one, just to give it a shot. Always start by counting how many atoms of each element you have on the reactant side and the product side. And I like to do that just by making a little table. Put an R on the left side for reactants and a P on the right side for products. I look at the reactant side, I write down what atoms I see. I see iron and I see chlorine. Same thing on the other side. I like to keep the elements next to each other so I can compare them. So, how many atoms of iron do I have on the reactant side? You can put it in the chat box. How many atoms of iron do I have? Yep, we got a couple of votes. Yeah. So we've got one iron. How many chlorine atoms do we have? Yep, we've got 2. What about the product side? You can do, tell me iron, comma, chlorine. What do we have? Yep, we've got 1 iron and we've got 3 chlorine atoms. So you guys are on it. So clearly the iron is balanced, but the chlorine atoms are not. We've got an extra one that appears on the product side. So we have to use the lowest common denominator between the two. So lowest common denominator. Which I will abbreviate LCD. So the number that both 2 and 3 you can multiply something and get this lowest common denominator. So in this case, the lowest common denominator is 6. You multiply 2 by 3 and 3 by 2. So if we're going to fill this in, we're going to say, okay, we have 2 chlorine atoms on this side. To get 6 chlorine atoms, we're going to fill in a 3. And to get 6 chlorine atoms on the product side, we're going to fill in a 2. If I fill in a 2 for this iron 3 chloride, that means that I now have 2 iron atoms on the product side. To balance that, I need to add a 2 on my reactant side. So you're pretty much starting with the most complex atom that you have, where there's 2 of one and 3 of the other or something like that. And then you start by balancing out that number with the reactant and product side. Then you fill in everything else accordingly. Now we have to do our check. For iron, with our new coefficient, we have 2 atoms. And with our new coefficient with the chlorine, we now have 6 atoms of chlorine on the reactant side. If we look at the product side, we have a coefficient of 2 in front of our iron 3 chloride. So that means we've got 2 iron atoms, and then we multiply the 2 coefficient times the 3 subscript for the number of chlorine atoms, and we get 6. So now we're balanced. And if I could spell balance today, we'd be good. Okay. So that's one example of how to balance an equation. And this is a pretty simple one. So I'm going to have you guys practice with a simple one like this. But before we do that, are there any questions? You can write it in the chat box. If you have a question, let me know, because we can walk through this again, or I can just give you one to try on your own, and then we can go over it together. So how many people want to have an example to try on their own? Raise your hand. Okay. We got a couple of people. Okay. So let's go on. I'll give you one to try. And again, that should be an arrow. The internet does not like my arrow. I don't know why. But I don't like you either, internet. So here's yours. You have iron solid combining with oxygen gas to generate iron 3 oxide. As an aside, to practice for chapter 6, you can name the compounds. So you can name this product. So when you go back and you do practice naming the compounds that you see. That will help you practice chapter 6. So go ahead, give it a shot, and I'll give you maybe 2 minutes. We'll see how far you get, and I'll have you put in the coefficients that you get for each of these in order, like, the coefficient for iron, then for oxygen, and then for the iron 3 oxide. Give it a try. I'm going to start setting up the problem. As you finish, you can write the coefficients for iron, for oxygen gas, and iron 3 oxide to separate them by commas. Does anyone have an answer? You can raise your hand if you want me to go over the problem. Okay, we have 1 vote for go over the problem. Okay, and we have 1 vote for. Okay, so most of us want to go over, a lot of us want to go over it. All right, so we'll check your work, all right? So here we go. I've already set up our table just to see how many atoms of each element we have on the reactant side and the product side. So hopefully everyone was able to get this far to set up this table. We have 1 iron atom and 2 oxygen atoms on the reactant side, 2 iron atoms and 3 oxygen atoms on the product side. So clearly we are not balanced. What we're going to do is we're going to try to balance this oxygen first. Our lowest common denominator is again going to be 6 for 3 and 2. So on the product side, we're going to multiply everything by 2. And on the reactant side, for the oxygen, we're going to multiply that oxygen gas by 3. So I'll start my new table. We haven't talked about the iron yet, but we're getting there. So by adding this 2 on the product side, we now have 6 atoms of oxygen. By adding the 3 to the oxygen on the reactant side, we have 6 atoms of oxygen. So that balances. Great. On the product side, we have 2 atoms of iron in each molecule. So we have to multiply 2 by 2 to get 4. Well, we certainly don't have 4 iron atoms on the reactant side. So that means we have to add a coefficient. And when we do, we get 4. So, Alexander, you were right. 4, 3, and 2 are the coefficients for these compounds. So let's try another one. I'll go through one, and then I'll give you another example. So this one's a little bit more complicated, but don't be afraid. You'll notice that we have some polyatomic anions here. You can count these polyatomic anions as a single group. So you don't have to balance the sulfur and all the oxygens and the nitrogens. No. So when you're looking at your reactants and your products, we'll write aluminum, and we have 2 of them because of the subscript. Then we'll just write down SO4. And then we have 3 of those because there's a 3 on the outside of the parentheses. So that subscript on the outside tells us we have 3 sulfate ions. Don't separate them. You don't have to. We have barium, and there's only 1. We have nitrate, and there's 2 of those. Again, because of the subscript. So why don't you look at the product side and fill in each of these. So we'll write them in the same order. You can write how many atoms or how many groups of atoms we have for each of these. So take a second and do that, and then you can write your answer in the chat box with commas between the numbers. Whenever you're ready, you can put your answer in. So looking at the atoms on the product side and trying to just tally them up so we can balance this thing. One for aluminum. I agree. We have 3 for NO3. I agree with that. I agree. We've got 1 for SO4. And 1 for barium. Thank you. So very clearly, we are not balanced. We've got some work to do. We're going to start with the most complex, and that is right here, the nitrates. We have 2 on the reactant side and 3 on the product side. Our lowest common denominator, which you'll see a theme, is 6. That happens a lot, where you have 2 on one side and 3 on the other, so the common denominator is 6. That means wherever we see the nitrate on the reactant side, we're going to multiply that by 3. And on the product side, where we see nitrate, we're going to multiply by 2. So let's start our new table here. And I like to keep everything in the same order, because that way you're less likely to make a mistake. So with our multiplication here, we end up with 6 nitrates on the reactant side and on the product side. Since we did that, we've now messed with the aluminum. So instead of having 2 aluminum on the reactant side and 1 on the product side, well, now we've got 2 on the product side, and that will match our 2 on the reactant side. You see that? We added this 2, and we multiply 2 times 1 for the aluminum. So now we have 2 aluminum atoms on the product side, and that matches the 2 that we have on the reactant side. We added a 3 for the barium nitrate, which means that we now have 3 barium atoms. Oops. So now we have to fill in 3 over here to balance it out. Our sulfates, we already had 3 on the reactant side because of this subscript. And now that we have 3 in front of the barium sulfate, we also have 3 sulfates on the product side. So you have to go back and forth and fill in the things that have changed. And when you do that, you see that everything is balanced. So don't let those polyatomic ions scare you. Yeah. If you have a question, you can write it in the chat box. And whenever you have a question, so which number goes before the first aluminum? You don't have to put anything. So that's a 1, okay? That 1 looks like an I. So you don't have to put anything there. If the coefficient is not greater than 1, you don't have to write it. So if you were putting an answer on an exam, you could leave the blank in front of the aluminum sulfate. You could just leave it blank. Generally speaking, for these kinds of questions, since we're doing an online format, it would be multiple choice. You're welcome. So it would be, which one of these choices, or what coefficient is in front of barium nitrate in the balanced chemical equation. So that's what it would be. So these, again, look more complicated than they really are. And another bonus for studying, we're balancing chemical equations. We talked about the different types of reactions last time. So you can quiz yourself. Some of these you will recognize, some of them you won't. But this, we have 2 aqueous solutions. And it yields a solid plus an aqueous solution. That's a double replacement reaction. So that's just a bonus. You can try to classify the reactions. You can try to classify the compounds, and that will help you practice all the other things that we've done in Chapter 6 and Chapter 7. Let's do some more. Oops, this should be a subscript here. My apologies. So I want you guys to try to balance this one. Remember that you can keep this phosphate together. So give it a shot, see how far you get. At least be able to set up the how many atoms of each element you have on the reactant side and the product side. If you can't do that, then we're in some really big trouble. I'll give you another couple of minutes to try to balance this equation, and then I'll start walking through it. All right, so we're going to go ahead and get started with solving this thing. Raise your hand if you are able to finish balancing the equation. Okay. Is anyone else able to finish balancing the equation? I know it's not a lot of time. Okay. So you've got a couple of people. So we'll walk through it, and I'll ask some questions along the way, and hopefully that'll get the rest of you understanding how to solve it on your own. So I filled in our chart for the reactants and the products, tallied up everything, and remember, we're keeping this phosphate together. It'd be a real nightmare if we were trying to balance everything and we separated it. This time we've got a choice. The sodium and the hydrogen both have 3 on one side, 1 on the other. So we'll just start with the hydrogen, just because you can. So here we've got a 1 and a 3. Our lowest common denominator, what is it? For 1 and 3, what is the lowest common denominator? I have a vote for 3. Anyone else want to take a shot? Lowest common denominator. We have agreement. 3. So that's pretty easy. When it's 1 and another number, that other number is going to be the lowest common denominator. So that means we need to multiply our hydrogens on the reactant side by 3. So I'm going to make my new table so I can start keeping track of this. I'm very much a creature of habit. I write everything in the same order for both tables so that I don't get confused. Now I said I was going to multiply the hydrogens by 3 on the reactant side. So that gives me 3 hydrogens on the reactant side, and I have not touched the hydrogens on the product side. That's staying the same. Now that I have multiplied the 3 times the hydrochloric acid, I now have 3 ions of chlorine. So I have to fill that in over here. If I have 3 over here on the reactant side, I need to have 3 on the product side. So I fill that in on my chart. Well, that actually works out well because we have 3 sodiums on the product side, or on the reactant side, and now we have 3 sodiums on the product side because we added this 3 here to multiply by. For the phosphates, we haven't done anything to those, so we leave that the same. So if you're going to fill in a number here, it would be 1 and 1. So our balanced equation, we have 1 sodium phosphate plus 3 hydrochloric acid molecules, yielding 3 molecules of sodium chloride plus 1 molecule of phosphoric acid. You should be able to name each of these compounds in this chemical equation. So again, you can practice your chapter 6 while you're balancing equations. You can name, you can classify the reaction, and you can balance. So that's a ton of practice all together. Questions, comments, concerns? This is going to be something you're going to have to practice. And there are lots of videos on YouTube that help with balancing equations. So if this didn't hit right or you need more, you can definitely go on YouTube and find more. I've already placed some practice stuff in the practice problems worksheet, or in the practice problems folder. So for chapter 7, there's a balancing equations. There's like 3 or 4 worksheets in there and the answers. So you don't have to wait for me to post anything online. The answers are already there. You just have to scroll down and you'll see the answers for each worksheet. So there's literally hours of practice that you can do, and you can check your answers. We'll go on and do, so this is the chapter 7, the mini problem set. So it should post to Blackboard at noon. So I'm going to check and make sure that it does. You're going to have to balance 2 equations, and then you're going to tell me how many atoms of each element are in these 2 compounds. And keep in mind that there are coefficients here. So that matters. Man, my spelling is pretty off today. Sorry, y'all. So that's going to be the chapter 7 problem set. If you want more practice with me with balancing equations, you can join office hours. I'm going to close this room for a little while, and then I'll reopen it again. And if you want to do some more practice, more guided practice, we can do that together. I'm not going to go over the homework problems, but we can go over some of the reactions on those worksheets that I was telling you about. And there's also the chapter 7 practice problem set that's posted along with an answer key. Questions? I don't see any questions coming through. So we can take a minute to talk about the exam. We have a few minutes. So for the exam, yes, I am going to have office hours on Monday for the exam. If you plan on attending office hours, give me an idea of when would be best. So post right now in the chat and let me know when would be best. I can't promise that I can accommodate everybody, but I can throw in a couple of office hours on Monday. And if nobody shows up in the first 30 minutes, then I may dip. So y'all need to show up, okay? Because that's outside of the times that I normally have, okay? So write in the chat box what times on Monday would be good. Okay, 1 to 2. Okay. Okay. So if I did 1 to 3 on Monday, would that accommodate a decent number of people? Okay, Brianna is all the exclamation points. Okay, good. All right. So 1 to 3 p.m., I will be in this room that we're in right now, the Chem 103 Section 4 room. And we can go through the exam review that's also going to be posted on Blackboard. So make sure that you give that a try over the weekend. There's going to be balancing equations, naming, and all that good stuff. And you'll get a flavor for the types of questions you'll see on the exam. If you have any questions between now and Monday, you can always email me. So this problem set, the mini problem set, the second one for chapter 7, that one is going to be due Monday before midnight. So try it over the weekend. If you still have questions, you can ask questions on Monday during those special office hours. Other questions for me? Anything else you guys need? I hope everybody's all right. This is just a real interesting time. So for those of you who are still on campus, I hope you're all right. For those of you who had to travel far to go home, hope your family is okay. Yes, I'm going to post the exam review right when we finish this class. I just have to make a couple of changes to it. And then I'll post that along with the answer key. But it's already pretty much made. You're very welcome. What I'll also do is, since we normally have extra credit points for being present for the exam review, if you do your exam review and upload it to Blackboard completed, then you will get the normal 5 points extra credit. So you'll see that on Blackboard. I changed so under the course materials and stuff like that, you'll see a link that says assignments and tests. That's what you'll click on, and it'll bring you to all the assignments and things that we're going to have due. You'll be able to upload your exam review, and that will be extra credit. So it will go towards your exam grade. That also has to be posted by midnight on Monday. So are we good? If we're good, then we can end class early. If you have questions, you want to do some more practice, then we can do that. I just need a few minutes. You know, being at home, it's a struggle. I've got my kids in the background. I'm hearing them play and do all the silly things. So it's definitely more difficult to focus. But I appreciate your patience. Yeah, thank you. Thank y'all. Y'all are great. I miss y'all. Please stay safe, okay? We'll have office hours at 12:30.